Okay, for those of you who wanted to make their characters a bit more cartoony, able to do more things than just a normal character rig might be able to do, there are a couple of things that we should be able to do rather quickly. I'm going to be going over these fairly slow, even though when I build them myself it can actually take me only a minute or two, each step of the way, and I can get them done within 5 to 7 minutes, even if I started from scratch. What we're going to be talking about today is the essence of creating what's known as a stretchy spine. Now, a stretchy spine means that if I grabbed the top controller and pulled it away from the waist controller, rather than the chest simply limiting itself and having to stay where it is while you drag the controller away, the scale of the joints are actually going to follow along so that it is as tall as the object that you're dragging. So the first thing that we're going to do is I'm going to move over to my front view, because we're of course assuming that your front view is where your character is going to be facing. And I'm just going to create, holding down the X key, 8 joints. And I'm holding down the X key so that each joint is the same length and it's just snapping up the grid. So here we have my little chain of joints. Okay. The next thing that we're going to do is we're going to create a spline IK. Now, you all know what an IK curve is, and if I grabbed hold of a IK handle and I made that, you could see that I could grab and sort of try to move it around. The problem is that because this is perfectly straight and it's supposed to be a spine, that's not going to do anybody a whole lot of good. So I'm going to delete that, and instead what we're going to do is this tool right here. It's the IK Spline Handle tool. Now, I can get to it from this little icon here, or I can go up to Skeleton, IK Spline Handle tool. Now, I'm going to reset the tool, okay, and that way we can all have the same options inside of our tool boxes. But what we're going to do is we are not going to auto-parent the curve, and we are not going to root on the curve. Okay, just going to turn both of those off. The rest of it's perfectly fine. And I'm going to start from the base of the spine and go all the way up to the top. Now keep in mind, this is for a bit more complicated rig, which means that if we were to build the arms out like this, we wouldn't really be connecting these. So the arms and even the neck and even the waist are not actually going to be physically connected to these joints, but they are going to all move around together. Okay, so just trust me on this. Now, if we open up our hypergraph, you'll see that among all of the joints we have the IK handle, but when we select this IK handle, we see down here, warning, some items cannot actually be moved in 3D. Now the reason that that option or this warning is being popped up is because this is not like a normal IK handle. It is being controlled by this, a curve. Now it's a little hard to see this curve, so what I'm going to do is I'm going to go to Show inside of my viewport and say Show None. And then I'm going to bring back Just Show Me Curves. And there it is. So just keep everybody aware, I did not turn or delete anything off. All I did was hide the other piece. Okay. Now I'm going to right click on this curve and I'm going to grab the top vertex. Then I'm going to go into a different view so you can see what's about to happen. Then I'll just make a second perspective view. That way we can see what we're looking at here. Okay. So this view can see everything. This view can only see that curve. So I'm going to go to Control Curves and I'm going to select it and I'm going to move it. And look what's happening. This spline curve is controlling where my joints are. And any of these points will change the position of this curve. Okay? Now I'm going to just undo so that that curve goes back to being straight. And remember back in the day one of the very first things that we talked about was how to create a simple method of controlling individual points without actually having to animate these points. We instead created a deformer known as a cluster. So now if I have this cluster, if I can select it, well, I can also select it from here. I can select that cluster and it will move the curve for me, which then moves my joints. Now the nice thing about a cluster is that it is selectable, though it is a little hard to select because it's lower on the food chain than an IK handle or a joint. But that's perfectly fine because we're not planning on selecting the joints to animate either. But what we do want is we want to be able to select each one of these and create a cluster for it. So I'm going to simply go down and create a cluster for each one. Now there is a way inside of your Edit Curves option that it will actually automatically clusterize this curve. The problem is this. If I go into my attributes, you can see that the cluster that I created, because I am creating it from here, default is this little option relative is turned off. That's an important aspect of this. If I were to parent that cluster onto some other object and start animating the other object, if relative was turned on, that little cluster usually won't follow along even though it's physically attached to the other object. So I always just create all 4 of my little clusters by myself. Okay? Now, the next thing I'm going to do is I'm going to create a NURBS circle for each one of these clusters. So I'm going to hold down my V key and snap, duplicate, hold down my V key and snap, duplicate, hold down my V key, snap, duplicate, hold down my V key and snap. Now, in order to make it easier to see, I'm going to I'm going to enlarge the top and bottom, just so that the center point, we can see easily that the center point controls, these little circles here, are less important at this point. Okay? Now sometimes the chest control, which is what I would assume this is, and the waist control, which I would assume this is, don't necessarily have to be circles. I actually like to create whole 3-dimensional boxes to make a chest and a waist, just so that it's a difference we can see. But that's not absolutely important right now, and you can make those choices later. Alright, so I'm going to say show me deformers so that I can see my clusters, and then I'm going to take each one of my clusters and simply shift and parent them to the corresponding ring. Okay, so now all of the clusters are now attached to their corresponding ring, and I'm going to select all of my rings and freeze transforms. That way when we look at them, each of them is now sitting in their 0 position. Okay, and now what I'm going to do is I'm going to select each of the clusters and Control H just to hide them. They're doing their job, we just don't need to see them anymore. Okay, what I'm also going to do is I'm going to take this curve and I'm going to look at it. Okay, notice how inside of the inputs we see each one of the clusters that are currently controlling it. Well, believe it or not, this curve actually has information that we can add to it even if we can't actually see it yet. Okay, so what we need to do is we need to say the length of this curve as it sits right now means that the joints that it's controlling are set to 1. However, if I make this curve longer than its original position, these joints must scale equally to reach that height. Okay? Now, it sounds really complicated, but believe it or not, it's not that bad. But the first thing that we need to do is we need to write a tiny little script. Now, script writing can be simple or very, very complicated. It all depends on how you look at it. And this one, fortunately, isn't too bad. I'm going to select the curve, and I want you to watch over here right as I hit enter. But for now, follow my mouse down to the bottom. I'm going to go over to my Mel script window, which is this little here. And by the way, if it says Python, just click on it until it says Mel. Mel stands for Maya Embedded Language. It is the language that is happening as you're doing everything inside of Maya. But this time, we're going to tell Maya to do something directly using her own language. So what we're going to do is we're going to create a node that says what the length of this curve actually is. And it's known as an arc length. Okay, so what we're going to type is all lowercase ARCLEN. Okay, arclen. That is the short phrase, which means I want a measurement for this curve. Now, there's a little shortcut, and you just go -CH, and what that basically means is channel, and then the word true. And when I hit enter, this pops up, a curve info node. Now, we can't really see much about it, but it exists, which is important. I'm going to hit Control A so I can go into my attributes, and you can see that the standard information about what a curve is, plus all of the information about the clusters that are controlling this curve are here. And if I go one more further, there's my curve info. Now, it says that my arc length is 7 measurements tall. Now, it's fairly easy to see that it's 7 measurements tall because I can use, I can use my measurements and just say, well, it's 1, 2, 3, 4, 5, 6, 7 equal units tall. The trick is, not every single curve is going to be the same length. Now, how on earth are we going to make 7 tell the joint's scale to stay 1? Well, this is where we get to use a couple of little nodes that will do some math for us and give us an answer that we can then plug in to those joints. But the first thing that we needed was that measurement. We cannot do the rest of this without that. Okay, so remember, if we wanted to create one of those, I'll type it out again, but I will not hit enter. It's ARCLEN, just tap a space, the -CH, and then the word true. Then hit enter. Now, if you've already created one of these curve info nodes and you do that again, just plan on having more than one curve info node. Okay? It won't really mess you up unless you start to get confused about which one you're actually using. All right? Now, the next thing that we're going to do is I'm going to just clean up my work area a little bit so that we're focusing just on what we've got. Maya 2013 has introduced a new window. It actually is underneath Window, and it's here underneath the Node Editor. And this is what it looks like. Now, some of you may be familiar with older versions of Maya, where if I were to open up my Hypershade, we can see that our work area looks very familiar. You notice that these little buttons here are the same buttons here, and some of them are different, but many of them are very much the same. Well, that's because this new node work area is essentially this work area inside of here. Okay? Now, if I were to create a new node over here in my Hypershade, say for example, I created a Lambert. If I come over here inside of my node editor, I can see my Lambert. And the only difference is that the little connectors that used to be over here, we used to have a pick whip. It's just not working anymore. I think what's happening is Maya 2013 really wants you to use this window. So if you've ever watched a video or you're watching other video tutorials and you see people working inside of this work area, just be aware that it's now the node editor that people are using, and it's not really that much different. Okay? Now, it's kind of funny because now we need a create node window, which ironically also looks like the other half of my Hypershade. So imagine that what they've done is they've created two smaller windows in order to make what I'm about to do when I usually just used to make it here in the hypershade. Okay, so now that that little bit of information is taken care of, I'm going to show you how to do this. Now I selected my curve and I hit the down input and output connections. Okay, that means lay out everything that this curve is made of. And it looks like it's just absolutely insane. This is why Maya is known as a node-based program, because behind the scenes this is really what's happening. But don't freak out, because there's not a lot of this information that we absolutely need. What we're really looking for is this right here. And it has a little green eye, and it's called the curve info. This tells us, if I go into my attributes, how long my curve is. Now the great thing is this. If I grab this and make it longer, the curve info node changes its number, because it really is calculating the physical length of this curve, which is very important for the next step. Okay? Now, the next thing that I need to do is I need to find a way to get this number, whatever this curve info's length is, and yours might be different. Yours might be 12, yours might be 1.3, yours might be 50.721. We need to figure out a way to get that number down to always be 1. Now, how can we, using math, make this number 1? Now, you can pause it and think about it really hard, or you can just let me answer it for you. There is a little node called a multiply or divide node. And what this little multiply divide node does is it takes in an input number and then does some sort of operation, mathematical operation, onto another number, and it spits out an answer. So if I take the number 7 and I divide it by 7, what's my answer? Hopefully that one didn't stump you. It's 1, which means we can take that number and then dump it into the spine so that the number is always 1. But the problem is, what happens when I start to drag it taller? Because now this number is no longer 7. Well, that's why, just going to set this back to 0 for you. That's why, instead of this first input just being a number that I type in, I'm actually going to regular click right into this output dot and see, here's the arc length. Now I have a little pick whip that I can drag over to the input of the multiply divide, and when I left click onto it, I can choose input 1 x. Now remember that on the multiply divide, 1, 2, 3 is always x, y, z. So it's asking, where do I want to plug it into? And I said, I want you to plug it into the input of 1 in the first window. Now, it would be easy enough for me to say, I want you to do it in the y, I want you to do it on the z, but that's unnecessary. Right now, I'm just going to focus on these two numbers right here. So, if I want to, I can set all of those back to 0, I can ignore them, or I can just pretend like they're not there. But what I'm doing here is I'm now taking input 1, which is 7. Now, why is this 7? It is 7 because that's how long the curve is. But what happens when I start to drag it up? Now the number is no longer 7, so multiply divide also calculates that new number. And this is the trick. This is the really important part, because we're still going to divide it by its original length. By dividing it by its original length, we're going to get a fraction. And that fraction is going to tell every single joint just how much longer they should be. Now, if it still doesn't make sense, don't worry. We're going to do it a couple of times, and it'll really start to make sense, okay? Now, there's one more thing that I want to do. Because I'm not just going to allow this to become anything. Because what happens when I have a curve info node that now becomes shorter? I now have something that's 5 and I'm dividing it by 7. Well, that means that the joints are going to actually get smushed down. Now, this is going to be entirely up to you. Do you want your character to be able to smush down in their torso, or would you much rather only allow it to be stretching? Okay? Again, this is going to be entirely up to you. But I'm going to do it both ways. I'll show you how I do the first way and then how to do the second way. Now, if I just want this multiply divides answer to be plugged into those joints so that if it gets bigger than 1, then it will become longer. And if it becomes an answer smaller than 1, then it will become shorter. All right, so in order to do that, all I have to do is select all of the joints that make up the spine, and then I'll shift and select the multiply divide. That way I won't accidentally lose it. Oh, something happened. Let me grab those again. Okay, so here are my joints, and now I'm going to come back over to my other node. Let's see here, grab you, down channel. There it is. Okay. So what I did is I grabbed the curve, which I know has the multiply divide node I need, and the joints. So I'm going to drag these over, and then there's my little multiply divide. Now what I'm doing right now is I'm dragging them away from the rest of the stuff that I don't need. None of this stuff is necessary for what I'm doing, so I'm just going to tuck those off screen just so that it's a little easier to work with. Okay? So this is what I have. I have my curve info node and the multiply divide that we made, and then I've added in my joints. Okay? Now what we're going to do is I'm going to check and make sure that these joints are scaling for x. As you can see, again, 1, 2, 3 is x, y, z. So here's my x. So what I know now is that the output of x, in other words, the answer of that division, will become the scale of x. And I'm going to do that for each one of these. So out of x becomes the scale of x. Now, it doesn't mean that it always has to be x to x. Depending on how you've made your math, it might actually be a y. But remember, if you're doing this the way that I'm doing it, it should be the answer output of x to the input scale of x. So once I've made it all the way down this chain, and it's not necessary to get the tip of the joint, this like all the way up at the top. I didn't even select it, so it's not in the list. So just make sure that if this little nub at the end is in your list, that you're not actually using it. Okay, it should just be the last full joint. So out of x to the scale of x. So this is basically what it should look like. The curve, which is currently 7, is being divided by 7. The answer is 1. And it's 1 for each one of these joints, which is great because that's what I need. Now, watch what happens. Now if I take the top of this curve and I drag it, watch the joints. Notice how the joints are scaling to keep up with the position not just of that point, but of the entire curve. That's the important part, because the curve info node is currently 19.3. Now, if I pull out my calculator and I type in 19.366 and I divide it by its original number 7, what we get is 2.766. Now, let's see if that math is happening here. So we have a curve info node of way more than it used to be, and it is currently 19.366 divided by 7. Now, if I come over to one of these joints 2.767. 2.7665. So you round it off and you get 2.767. The reason that this is working is because the math started out allowing these curves to make 1. Now, as I start to drag the bottom, it might seem that it's not quite working right. Well, that's because the joints and the curve aren't parented properly. But now it is. So what I actually did was I just took the joints and parented them directly to that bottom curve. So the actual spine joints are physically connected right there to my curve. So my waist curve control is telling my joints what to do, and then the curve is telling everything else how to move. Now I can take the center points and I can move them, and the longer that I make them, the more the joints get scaled. Now you can see very easily how if I have too few joints, it might start making a problem for my geometry. But it all depends on exactly how complicated I'm really trying to make it. Do I want this character to actually be able to scale itself to 5 or 6 times its original length? And if so, is straight and just a little bit bent enough? Or are you really looking to make crazy distortions of your character? But that all goes back again to rule number 1. What does your character have to do? Okay? Okay, but what I mentioned previously is this one's working great. This one's stretching. But what it's also doing is it's shrinking. Notice how the shorter I make this, the smaller my joints are becoming until it just can't handle it anymore. If I drag all of these center points and everything down, I can make it to the point where this has nearly flattened itself out. So you see that the math is now a fraction. It's a quarter of what it used to be. And that's because the multiply and divide doesn't know whether or not you want to just make it stretchy. Okay? Now, in order to make it only stretchy, this connection, this final link, is wrong. So what I'm going to do, and remember, this is for your benefit whether or not you choose this way or the way that I'm about to show you. If you're looking for a character that only stretches but does not squish down into relative nothingness, I'm going to grab all of these little connections and just hit delete. That will break that connection without doing any real permanent harm. Okay? I need to come back and grab my node window. And what I'm going to do is I'm going to type and find a condition. I normally say, remember when you were a kid and your mom said, you can go outside on one condition. What she meant was, if you clean your room, or if you take out the trash, or if you mow the lawn, then you can do something. Well, that's what this condition is. The condition says, if something is either greater than or equal to, in other words, if whatever I'm saying is true, then this will happen. If something is not true, in other words, if you did not take out the trash, then something else will happen. Okay, so if you can think about it like that, it's going to be a lot easier to understand how this works. So, what I'm going to do is I'm going to take the output of my x, the answer of my multiply divide, to the input of the first term. So as you can see, the first term is currently 1. That's because all of these little curves are now set to its default position. So that means that all of the joints are also scaled to 1. The second term is also going to be 1. Now what I'm saying is, if I'm choosing greater than, the operation, if number 1, the first term, is greater than the second term, then if that phrase is true, something happens. If it is false, everything stays to 1. So if this second term is not smaller than the first term, so let's do this. Then what's going to happen is output x to the color if true r. Now, what did I just do? I took the answer, the mathematical answer, and I stuck it first to the first term. Meaning, if the curve becomes longer than 1, then something has to happen. And the color if true, the answer, if something is supposed to happen, that's also what the difference is. So as I start to pull this a little longer, we start to see that now we have 8.2 being divided by 7. Is our answer going to be bigger than 1? Well, to sate your interest, yes, it's actually going to be. Notice that now the first term will be 1.174. So we have to ask ourselves, is the first term greater than 1? If it's true, the scale of your joints gets to be 1.174. However, if it was not, the joints wouldn't scale and they would simply be stuck at 1. So that means that when this starts to get too short, it says first term is 0.79. The question is 0.795 greater than 1? If the answer is false, then the joints do not scale down. And that's how we do it. Okay, so let's plug this all back into our joints to see how it works. So once again, I'm going to take my joints, go to Edit, select Hierarchy. Now I have all my joints. And I can shift and select my curve. That way I'll have everything I need. So here are all my joints. Slide these over. And I'm sliding them over just so that I don't have to deal with all of that other stuff. All this other stuff is unnecessary. I'm just going to push those out of the way, off the screen. They're no longer in my way, so I'm happy. So I'm going to slide these a little bit further. And here's my condition. And what I'm going to do for each one of these joints, I'm going to say that the out color R, because remember, just like I said, 1, 2, 3, we have 1, 2, 3 is X, Y, Z. Well, it's also R, G, B. So we're still working on this area. We're ignoring Y and Z. So it's going to be the out color R to the scale of X. And again, the out color R to the scale of X. And we're just going to do that for each one of these. And I wanted to make absolutely sure that I didn't include the little nub at the top. And I can see that I didn't, so scale X. Now what we've got is a set of spine joints that will get longer, but will not get shorter. This way you can ensure that some of your characters will be able to stretch a little bit, but it'll be much harder to squish them. But that's okay, because if the character was supposed to be a little bit more moving believably, then in order to squish down, they would actually have to bend down. And that's what that's for. See, now you can actually position them so that they're bending forward instead of squishing down. So remember, it all depends on how you personally want your character to be able to function. All right, and the last thing that we're going to look at is how to properly get your character or get your torso to twist properly. Okay? Now, this is going to be much easier if you followed along and you did like I did. If you created your joints up the front axis, then this is going to be a piece of cake. Before we do anything else, go ahead and grab your joints, go to Edit, and say Select Hierarchy. What we need to do is we need to make absolutely sure that all of these joints are facing the right direction. Now, this is something that you can do prior to this. In fact, you can do this before you even set up the entire rig. But I want to show you how all of this works together. And like I said, if you created your joints along the front view, then this is already going to have taken place. I'm going to hit F8, which is on a PC. If you're on a Mac, go into component mode, which is up here, and just hit this question mark. And what you're going to see is that all of my joints, and don't worry about the top joint, that's not necessarily part of this equation, all of my joints are facing the right direction. Okay? Now, it's going to be a lot easier if I can select other objects and yet still see those orientations. And unfortunately, component mode doesn't let me do that. So what I'm going to do is I'm going to select my joints, go to Edit, select Hierarchy, and this time I'm going to go over to my skeleton, and I'm going to go to Orient Joint. And I'm going to just toggle this little button right here. It says Toggle Local Axis Visibility. So I can now let go and select anything else, and I can see which direction my joints are facing. This is going to be a lot easier for you to tell whether or not your twisting control is actually working properly. Now, before we begin, I'm going to first name my hips control. So I'm going to call this capital HIPS underscore capital CTL. And then I'm going to name my chest control CHES chest, that's with a capital C, and then CTL for control. Now, it's very, very important that you don't forget what these are named, because that's how we're going to be able to remember or to control how this twisting happens. So a good little trick here would be to just have your hypergraph open so that you can see how you named hips and chest. Okay? So just tuck that away for now, and we'll keep moving. Now, we're going to select the actual IK handle. And remember, it says, hey, you can't move some elements inside of 3D. That's totally fine. I just want to get to the attribute editor. Because inside of the IK solver information, you have to drop that one open first. Then, just below that is something called the Advanced Twist Controls. Now, when we pop that open, currently we have nothing on. Now, when I click this button, look what happens over here. Alright, don't freak out, and if you already have a character geometry, don't freak out that it just went bonkers, okay? We don't have everything set up properly yet. So, we're going to go to Scene Up, and instead we're going to do Object Rotation Up, Start and Stop. Now what we're basically saying is the world up. In other words, the IK handle has to know what it's supposed to look at for reference. What is going to tell me what my normal state is. Now, remember, the forward, the facing angle for us is the Z. So I need to change this to positive Z. Now, the up vector and up vector 2, what they're talking about is which direction are those facing. So, remember, 1, 2, 3 is X, Y, Z. So I need to change the Y's to 0 and change the up directory for Z in 1. Now, it looks like everything is working, but it's not yet. It hasn't figured out what is supposed to tell it how to twist. So, world up object number 1 is actually going to be the hips, because that's the direction that the joints are coming from. So we're going to call this, how did we name it? Capital HIPS underscore CTL. Then world up object number 2 is going to be the endpoint, and that was capital CHEST underscore CTL. Now everything is working right, because when I grab hold of the top and I twist the top, look at how my joints are rotating. And you notice that they're not all rotating evenly. This one, because it's closest to that joint, has moved the most, where this one, closest to the one that hasn't moved at all, is staying put. So we have this nice smooth transition. Basically, you're twisting your torso, twisting your shoulders side to side. And this means that when you start to rotate your hips side to side, like you're doing the twist, that all is going to listen too. Now, let's just put this arm, I'm going to mirror, and I'm going to grab both of these arms and just parent it directly to that control, just so that we have some reference to look at. And I'm going to start twisting. And notice how that's got that nice, really, really smooth transition. Well, let's say that we wanted to get a little crazy. So we're going to twist it into this crazy position, and yet I can still twist it back and forth. Now, this is the kind of thing that works with tails, it works with necks, it works with torsos, it works with anything that has a lot of joints that you want to be sort of rubbery or stretchy. We can also do something very similar to this using with our arms, but the arm controls are going to be a little bit tricky. And the reason that I say that is because the arms, we still want an IK handle so that we can put our character in its basic position as fast as possible. So we're going to get into that in another video. The next and last thing that we're going to do for this, have you noticed that when I grab the top and I pull it, the bottom stays where it is, which is probably correct, but these two little middle points, wouldn't it be nice if they just sort of floated into an even position? Well, we've done something similar to this before, but not necessarily for this particular reason. What we're going to do is I'm going to open up my hypergraph, and you're going to first see that this is my NURBS curve. This is the, and I'm going to name this upper center torso. And then I'm going to select this one, and I'm going to call this lower center torso. Oh, not torsi, torso. I'm going to select each one of these, and I'm going to create a new group for them. Okay? So, as you can see, we have a group, and I'm going to center pivot, and a group that we will center pivot. Oops. Okay? So now what we have is a group that we can attach a constraint to. Now, I'm going to give this a name. This is going to be lower torso GRP. And I'm going to call this one upper torso GRP. I'm going to take the chest, and I'm going to shift and select the torso, and I'm going to create a constraint, and it's going to be a parent constraint. Now what I have to make sure of is that maintain offset is on. So when I hit apply, it doesn't seem like anything has happened. Perfect. I'm then going to take the waist and do the same thing to the same group. So now we have two constraints on one group. So I'm going to do the same thing to the other one. Grab the bottom and apply. Grab the top one and apply. Now when I grab this center torso and I pull it, look what starts to happen to these controls. They're following along for free. But there's something a little off about where their position is. Because they're not going, this would probably be a bit more believable. The top one should go closer because it's supposed to be controlled more to the top, and this one should be more controlled to the bottom. So, just like what we were doing when we did the animation of the character picking up and putting down a ball, we can change these amounts, but no longer, instead of doing yes, you have it, so it's 1, no, you don't have it, so it's 0, we're actually going to allow this controller, the top one, so the chest controller is going to have 0.666 amount of influence, and the hips being further away from them will get 0.333. Notice how it's snapped up here now. This is going to allow me, and of course the lower torso will be just the opposite. So the hips will be 0.666 and the chest will be 0.333. And by the way, if you're superstitious, you can make this 0.667. That's fine. But notice that if I grab hold of my chest control now, as I move it around, oops, sorry, I started playing around with the position of those. There we go. So as I start to move my chest around, notice that the two middle points are moving beautifully and still staying. This one's closer to the chest, this one's closer to the waist. This is going to allow me to animate my character much faster, because just like we were doing with the elbow controls or with any other means of getting some things to happen faster, if I'm grabbing my character and putting him here, this is my chest, so I can arc it a little bit much faster than if I had to go find it. And notice that it still follows along, but I'm always free to adjust it as I need to. And yet all of them can go back to the original position. And the best part is, it's still listening to that nice clean twisting control. Okay? Now, this might have seemed like an awful lot of information, and yes, I know it is, but the beautiful thing is you can watch this video as many times as you need to, take notes, watch it a few times, take some more notes, see if you can make it happen, go back and watch it again. There might be some things that you may have missed. This is the sort of thing where once you get it, you got it. And it's just a matter of really taking the time to make it work. Okay, so good luck, and I look forward to seeing how you do.